In 1989, researchers pointed a low-light camera above a distant thunderstorm and accidentally recorded something pilots had described for decades. A red electrical shape appeared roughly 70 kilometers above Earth, spread across the sky, and vanished in milliseconds. Until that frame existed, the reports were easy to dismiss. Nature had produced an effect so large that almost nobody could prove they had seen it. And that is only where this countdown ends. The fire rainbow. This looks like a rainbow caught fire inside a cloud. It is commonly called a fire rainbow, which is an efficient name because both words are wrong. The real name is a circumhorizontal arc. It does not require rain, and nothing is burning. It forms when sunlight passes through flat, hexagonal ice crystals in high cirrus clouds. For the geometry to work, the sun has to be at least about 58 degrees above the horizon. The crystals also need to be floating in roughly the correct orientation, like millions of tiny glass prisms that have all received the same irritatingly specific instruction. Light enters through a near vertical side of each crystal and leaves through its horizontal bottom. Different wavelengths bend by slightly different amounts, separating white sunlight into an unusually clean strip of color. Because the sun cannot climb high enough at some latitudes, certain places may never see a complete one. The photograph is real. The name is doing most of the lying. Nothing burns, no rain falls, and the entire display depends on sunlight meeting ice at one annoyingly precise angle. Glowing waves. At night, an ordinary wave breaks, and the entire shoreline flashes electric blue. Every footprint glows. A hand moving through the water leaves a trail of light. It looks like a computer effect that would be rejected for being too obvious. The light is biological. Coastal blooms can contain huge numbers of microscopic organisms called dinoflagellates. Some species produce a short flash when the surrounding water is disturbed by a wave, a swimmer, or a boat. Inside each cell, a rapid chemical process releases energy as visible light. In one well-studied group, a voltage-sensitive proton channel helps trigger the acidic conditions needed for that flash. The effect probably works as defense. A sudden burst may startle a grazer, or illuminate that grazer so something larger notices it. One microscopic animal turns on a light, and something higher in the food chain receives a dinner notification. Bioluminescent water is not automatically dangerous, but it is also not permission to drink the sea. Some dinoflagellate blooms can produce toxins, while others do not. The blue glow tells you that living cells are making light. It does not provide a safety certificate. The sailing stones. Across Racetrack Playa in Death Valley, rocks sit at the ends of long trails carved into the dry lake bed. Some trails run straight, others turn sharply or cross one another. There were no footprints, no drag marks from people, and for decades, no one had actually watched the stones move. Theories blamed powerful winds, dust devils, algae, and thick ice. Then researchers placed GPS instruments inside selected rocks and installed a weather station. In December 2013, they finally saw the movement happen. After a rare winter storm, a shallow pond formed across the playa. Cold nights froze its surface into sheets only a few millimeters thick. When the morning sun weakened and cracked that ice, light winds pushed large, floating panels across the water. The panels pressed against the rocks and slowly shoved them over soft mud. The stones moved at walking speed or slower, sometimes for minutes at a time. The solution required water in a desert, freezing nights, morning sunlight, thin ice, soft mud, and just enough wind. Miss any one condition, and nothing happens. The mystery lasted so long not because the mechanism was supernatural, but because Death Valley arranged the experiment only when nobody was watching. Hole punch clouds. A perfect circular opening appears in a flat sheet of cloud. Wisps of ice fall from its center. From below, it resembles a portal, an explosion, or the moment the sky failed to load properly. It is called a fall streak hole. The cloud layer contains supercooled droplets, liquid water colder than 0 degrees Celsius that has not yet found a suitable structure on which to freeze. When an aircraft passes through, the rapid pressure change around its wings or propellers can create ice crystals. Those crystals give the surrounding droplets a way to freeze. The new ice crystals grow and begin to fall. Water vapor shifts away from the remaining droplets and toward the ice, causing liquid droplets around the opening to evaporate. The clear patch expands, while falling crystals create the feathered streak in the middle. So, yes, an airplane may help punch a giant hole through a cloud, but no, it is not a secret weather weapon. It is just aviation accidentally drawing circles with thermodynamics. Blood falls. At the end of Taylor Glacier in Antarctica, dark red liquid stains the ice. Against the white landscape, it looks less like a waterfall and more like the glacier has injured itself. The color does not come from blood, red algae, or a failed horror film. It comes from extremely salty, iron-rich brine emerging from beneath hundreds of meters of ice. The salt lowers the freezing point, helping the liquid survive in an environment where ordinary water would become solid. When the brine reaches the surface and meets oxygen, its dissolved iron changes. Detailed analysis found tiny, amorphous, iron-rich particles, rather than the simple, crystalline rust people often imagine. Together with other ions, those particles produce the red-orange stain. The hidden water is more interesting than the color. It is part of an isolated subglacial system containing microorganisms that can survive cold, darkness, and very limited resources. The salts retain a marine history, and the environment gives researchers a possible analog for liquid habitats beneath ice on other worlds. The red stain is only the visible edge of a buried ecosystem. Once the explanation arrives, the waterfall becomes stranger rather than less strange. The Morning Glory Cloud. Near northern Australia, a long white tube can stretch for hundreds of kilometers across the morning sky. It moves like a rolling wave, often in an otherwise clear atmosphere. Pilots travel to the Gulf of Carpentaria specifically to glide along it, because apparently seeing a cloud shaped like a planetary shockwave is not enough. Someone must also climb onto it. The Morning Glory is a roll cloud attached to an atmospheric wave. Around Cape York Peninsula, sea breezes can approach from opposite coasts and collide. After sunset, the land cools, air descends, and a stable inversion forms over the warmer water of the Gulf. Under the right conditions, that descending air slips beneath the inversion and launches a series of waves. At the front of a wave, air rises and cools, so water vapor condenses into cloud. Behind it, air sinks and warms, so the cloud evaporates. The cloud is not a solid tube rolling forward. It is continuously forming at the leading edge and disappearing at the back, like a shape being rebuilt while it moves. These clouds are rare globally, but around the Gulf of Carpentaria, they appear with unusual regularity, especially from September to November. One of the strangest clouds on Earth has, for reasons known only to atmospheric physics, a preferred appointment window. Volcanic lightning. An ash column rises from a volcano, and lightning begins firing inside it. No storm has arrived. The volcano has built its own. Close to the vent, fragments of rock, ash, and droplets collide and exchange electrical charge. Higher in the plume, water freezes, ice and hail-like particles interact, and the charging process begins to resemble a severe thunderstorm. Once enough positive and negative charge separates, the air breaks down and a lightning channel forms. The eruption of Hunga Tonga Hunga Ha'apai on January 15, 2022, pushed this mechanism to an absurd extreme. Researchers counted just over 192,000 flashes during the eruption, with a peak above 2,600 flashes per minute. Some occurred between 20 and 30 kilometers high. The lightning even formed expanding rings as large atmospheric waves moved through the plume. Those flashes were not only visual chaos. Because satellites could not see through the thick ash, lightning sensors helped scientists reconstruct changes inside the eruption and showed that major plume activity continued for at least 11 hours. The eruption built its own storm, hid inside it, and then revealed its movements through nearly 200,000 electrical flashes. Red Sprites. For generations, pilots reported brief lights above thunderstorms. The stories were difficult to verify because the events were faint, distant, and usually gone before anyone could turn a camera toward them. In 1989, researchers at the University of Minnesota were testing a low-light camera for a rocket mission. The camera happened to be pointing above a distant storm and recorded two luminous shapes. It was the first credible image of what we now call sprites. Sprites are enormous electrical events in the upper atmosphere. They often appear after powerful positive cloud-to-ground lightning changes the electric field far above a storm. In the thin air around the mesosphere, that field can accelerate electrons into molecules, producing a brief red glow. Some sprites look like columns. Others spread into branching tendrils that resemble carrots, trees, or jellyfish. They can span many kilometers, form roughly 70 kilometers above the ground, and vanish in milliseconds. A person beneath the storm usually cannot see them because the cloud blocks the view. To photograph one clearly, an observer may need darkness, distance, an unobstructed horizon, the correct storm, and a camera already looking at the exact piece of sky. That is why eyewitness reports existed long before convincing images did. The phenomenon was real. It was simply enormous, bright red, and exceptionally good at avoiding documentation. These events look fake for the same reason. Good visual effects look convincing. Both obey rules. Ice separates light at precise angles. Cells turn chemistry into blue flashes. Wind moves a sheet of ice, and the ice moves a stone. Electrical charge searches for a path through air 70 kilometers above us. Nature never has to break physics. It only has to combine familiar rules at a scale, place, or moment our brains were not prepared to recognize.